I'm Greg Peterson of the Materials and Processes Laboratories at Anaheim. You've seen a video on the general principles of ESD control, and now we'll learn about how those principles are implemented by our Anaheim site General Process Specification AA017-008. This specification requires that all personnel designing or handling ESD-sensitive items or supervising or monitoring those functions must be certified and have recurrent training. Next, the specification requires that personnel be protected from electrical shock. And to do that, we use a resistor in the wrist strap cord. Now, you've seen in an earlier video that the wrist strap is used to prevent the buildup of voltage on the operator's skin. Now, if the voltage builds up, the operator can zap a part with an electrical discharge, much like you would zap a doorknob on a dry day. To make sure that the wrist strap is functioning properly, we use continuous wrist strap monitors, as you see here. And when the wrist strap is plugged into the monitor, an alarm sounds unless the operator is properly grounded. And now John Collier of the M&P Labs will explain more about electrical discharge and the wrist strap monitors.
Hi. We're going to demonstrate how devices or static sensitive items can be damaged by discharges, and we're going to use two instruments. This is a pink static meter, such as you have in your areas, and this is a static event detector. The static event detector acts like a real device sensitive to 100 volts, such as a MOSFET. Now if we'll zero in on the meter, and you'll see that when a static voltage approaches the front of it, namely a field, we'll see the needle move. And that's all we need to know at the moment. This static event detector, as we zero in, consists of two parts. There's a base, which would be analogous to the substrate case lead of a MOSFET, and there's a cover, which would be like the gate lead of a MOSFET, for example. And when a voltage differential of more than 100 volts occurs suddenly between the case and the body, this little window will turn red. Now, for the rest of the demo, you'll be seeing the static meter and the static event detector in my hands close up. Now we see the meter, and I am bringing my hand near it, and I'm stroking my feet on the floor. I am not wearing a wrist strap. You'll see I'm generating a high voltage. And now, looking at the static event detector, zero in real close. When I touch it, you saw the window turn red. Now in the first test, I had no wrist strap. This time I'm wearing a wrist strap, but it happens to be a bad one with the conductor broken inside of the insulation. So, as you see, with a bad wrist strap, and I wouldn't know it was bad if I hadn't tested it, I'm getting very large voltage on myself. And now if we'll look at the static event detector, and we will touch it, once again, it's been tripped. Now I'm wearing a good wrist strap, and if you'll look at the needle on the pink meter, you'll see that there's no motion. And zeroing in on the static event detector, I can touch it all day long and never trip it. The window stays white. This time I'm wearing a wrist strap with two conductors connected to a continuous wrist strap monitor, and when either of the conductors fails, the monitor will alarm. But interestingly, now, by the way, you will notice the pink meter is showing no needle movement as I shuffle my feet because, of course, I'm grounded. The interesting thing about the continuous monitor is if the conductor should fail in one of these wires, the monitor will alarm, but you will still be grounded. Now I'm going to disconnect one. You'll hear the monitor alarm, and you'll see that the needle still doesn't move when I shuffle my feet.
When an ESD sensitive item is not in a static safe workstation, not shunted, or not in transit and being closely watched, it must be kept in a protective package. We use a so-called Faraday cage, which includes aluminum foil. The following demo will show why a pink poly bag is not adequate.
Hi, for our demonstration on static protective packaging, we'll once again use the pink meter, as you saw before. We'll once again use the static event detector. And now as we zoom in, we're also going to look at two protective bags. We have the familiar pink poly bag, which you can see through, and we have the foil bag, which we require as the outer protective covering. Here we see the static event detector again, and I've shunted the lid or cover to the base. This represents a device with the lead shorted, and such a device is by and large protected when it's out of a static safe workstation. Now again, I'll shuffle my feet and I'll touch the static event detector, and try as I may, I cannot trip it and turn the window red. Here we see the static event detector inside of a pink poly bag, and this time, without a wrist strap, I'm going to generate a charge on myself and touch the bag over the static event detector, and the static event detector has been tripped, turned red. You'll see it more clearly when I empty it out of the bag. There it is. Now, we just saw the static event detector was tripped inside of a pink bag, so now we're going to try a Faraday cage foil-containing laminate bag, as we are required to use. And I'm going to put the static event detector inside of it, slide it in there. Okay, now I'm going to remove my wrist strap, and I'm going to try real hard to trip the detector by touching it. Okay, and now we'll empty it out of the bag, and if you'll zero in, we'll see that it has not been tripped in this case. The Faraday cage bag has protected it.
But discharges are not the only threat to ESD-sensitive items. Static fields can also damage unbagged devices, so we have rules to stay a safe distance away from surfaces that can radiate a static field, as the next demo will show.
Hi. In this last demonstration, we will again use the pink meter and the static event detector, and this time we'll use a piece of polystyrene foam or styrofoam, which, as we zero in, this is a material which is definitely banned from workstations, and you'll see why. For the rest of this demo, the camera will be zooming in on these items in my hands. Here's the static event detector again. I'm holding it by its base, and now a piece of highly charged polystyrene foam will be brought up to it. And as you see, the detector was zapped by an air discharge through a considerable amount of space. The polystyrene foam never touched it. And in fact, static fields will damage devices at a distance in a similar manner.
At this point, we have the ESD-sensitive parts bagged when they need to be, static fields minimized, and people grounded, both the operator and visitors. But we still have to ground the workbench surface. This is done by a buried conductive layer in a hard laminate, or in this case, by a soft static dissipative mat, which is connected to ground through a ground wire at the laminate grounding lug or the mat snap. The M&P labs certify all benches and other workstations, such as ovens, for correct grounding and apply a certification sticker. Connections must be secure with no clips on wires or alligator clips. Well, I've covered the highlights. For other details, such as correct wearing apparel, you'll be reading the specification. Also, you'll be practicing QA provisions of the specification, such as scanning your workbench for dangerous fields with a static meter. In the future, or maybe by the time you see this video, we'll have continuous static field monitors that beep when a charged surface such as a common plastic enters the workstation. This concludes our brief lesson, and thank you for watching.